Welcome back to the tutorial on capturing mental representations through crowdsourced scoring. Again, please refer to the corresponding paper and the OSF repository for more information. And so in lesson 4, I'm going to tell you about how to save these drawings as data. So we get back these CSV files from either Amazon Mechanical Turk or from your own web server, or from Cognition or Cite Toolkit, whatever you end up deciding to use. But how do we turn these numbers and these pieces of text that we get in the CSV files back into meaningful information? Like, what are the drawings and what are the mouse movements? Well, to answer that question, we need to understand how is the data actually saved. So as I mentioned, the data is saved in a CSV file. This stands for comma separated value file. It is essentially a text file, so you can open it with the text editor. In this case here, for these experiments, instead of commas, we use pipes or these vertical bars because the data can sometimes contain commas. For example, we have that question of, have you taken art classes in the past? And so you can envision in their response, participants might include commas like, oh yes, I took a class in elementary school and middle school, etc. And so we want to use something like a pipe because that's not used in standard English text. And so just off the bat, in terms of how these CSV files look, the survey data is generally easily interpretable. The key question is just how to interpret the drawing data and the mouse movement data. And so when thinking about how a drawing is saved, the first key point is that it's easier to save text in a database than to save multimedia. It's easier to save a text-based representation of the drawing than some sort of JPEG. And so what we do is, as soon as participants complete a drawing and save it, we convert it to something called a base 64 encoding. So here's an example drawing, and here's what its base 64 encoding looks like. So instead of saving this drawing file, we're saving this text representation of the image. And so I'm just going to show you some examples of how to interact with this base 64 encoding. So we can open up one of our CSV files. So this is the example1 data.csv that comes in our code base with that first example. And so it first looks totally nonsensical and uninterpretable. Actually, at the top of the CSV file is where we define the names of the different columns, or it's basically our header. So this is telling us that the first column or the first variable is the subject number, and the second one is the representation of the first drawing. And so the subject number is just 1. And when I said that questionnaire text is generally interpretable, that's because you will see it as something like if you ask someone what state they lived in, it would look like this. So it would just be easily readable from the text. The only thing is just the base 64 representation for an image is not human interpretable. But we can easily turn it back into an image. So if we take this huge chunk of text, we can then copy it into a base 64 to image encoder. So this is just a web page that can convert base 64 to an image. And look, it's created our image here, and then you can just download that image. But instead of having to go through an online converter, in our code base, we've actually provided a few different scripts that can do this for you. So one of our reviewers, Jeffrey Wems, very kindly provided us with this Python script that can convert base 64 back to a drawing image. And we also have this functionality in our MATLAB script here that can also take this text and save it into the JPEG. And then it saves it into the save data folder. So here's a JPEG generated from that base 64 encoding. And so how is mouse movement data saved then? If we don't want to save multimedia information, how are we able to get around having a video of the mouse movements? Well, actually how we do this is we save the mouse movements as a series of coordinates separated by semicolons. And I put it in this sort of structure of X coordinate, Y coordinate, and time. So this is an example of what a mouse movement looks like, where X, that is a number of horizontal pixels from the left of the drawing interface. The Y is a number of vertical pixels from the top of the drawing interface. So that gives us a coordinate exactly in that square frame of the drawing interface. And then finally, the time is the number of milliseconds that have elapsed from the start of the trial. So as soon as the interface loads, I start the timer. And then when they hit, and then as they draw, it's tracking how many milliseconds after that timer start does each stroke occur. I also insert this arbitrary sequence of 9999, 9999, 9999 to indicate a new mouse click. So when they have released their mouse, in case it's useful to know when they've made different strokes. And so to reconstruct the mouse movements, we can work backwards from these coordinates. We can essentially take a blank canvas that's the same dimensions as our drawing interface, and then we can iteratively fill in the pixels at each coordinate. So we know that they were at this coordinate, let's say 100, 200, we can fill in a pixel there. Then they move to 101, 200, we can fill in a pixel there, etc. We can fill it in two different ways or with two different types of information. We can go to each coordinate and just fill it in with black. This is great because it lets us see when participants erased any information. It purely shows us the mouse movements without information on what the final drawing looked like. You can also fill in that pixel with the drawing color to reconstruct what the drawing actually looked like. So you would actually see, oh, they drew red here, they drew blue here, etc. But if they erased information, it would come up as white, so you wouldn't see that. Currently, at least in the way our code is implemented, there is no easy way to see, oh, they colored this red, then they erased it, then they colored it blue, because that would require saving even much more information with each coordinate. And already this is a large amount of information being saved into the database because we're sampling fairly frequently, several times per second. Then when we reconstruct a video of someone's mouse movements, we can iterate in two different ways. We can just iterate throughout from coordinate to coordinate relatively rapidly or in sequence, or we can also iterate throughout the coordinates based on the real participant timing. So we can say, draw this point here. Oh, then the participant took a break for 2 seconds. So let's wait for 2 seconds. Then they drew their next point here 2 seconds later, and then we can draw 2 seconds later, or we can do it immediately after if we don't care so much about the participant real-time timing. And so let me show you what this MATLAB script looks like that reconstructs these drawings and these mouse movements. So you can look at the example in experiment 3 or experiment 4. Those two are pretty much identical, and these are within our code base available online on OSF. And so I'm going to show you the view data experiment 4 example. And so what that does is it loads in the base64 converter. It reads through the CSV file using this read table command. It then saves the data in various ways. I encourage you to look at the comments for more details, but I'm just going to go over this sort of with a bird's eye view. So essentially what this part of the code is doing is that it's converting the base64 text back into an image and saving that image. Then this part of the code deals with the animations. It's creating a video file. It's finding where the boundaries are of the video. It's creating the first blank image. And then it iteratively goes through the different coordinates that it saved. It extracts those coordinates. It makes sure it's not that click up command that I have. It then gives the coordinates a little bit of buffer because you want there to be some width to your pen. So in this experiment, the pen was about 3 pixels in width. So this is making it so that anything we draw is 3 pixels in width. It's making sure we're not outside of the boundaries of the drawing. And then essentially here it is drawing in black dots at all of these coordinates or drawing in the color of the final drawing. And then it saves this all in a video. So what you end up with is a nice MP4 file of a video of the participant making those mouse movements that they performed when they were making their drawing. Yep. And in this example here, we actually have flags you can set for if you want the pen size to be a different size, if you want the timing to be real-time timing or just rapid timing. And you can also say whether you want to see the color of the final drawing or if you want everything to be in black. Yeah, and so the main takeaway of this lesson here is that while the data comes in as a fully text CSV file, that's no concern. It can be flexibly converted back to an image using base64 conversion and to a video by recreating mouse movements. And for you, when designing these sorts of dynamic experiments, it's helpful to think about how can you convert the sort of like rich multimedia information into text, because that tends to be both more secure and easier for databases to handle. And so in the next and final lesson, I'm going to tell you about, now that we have these drawings, how do we actually quantify them? All right, see you then.